So my name is John Nagle. I'm the CTO and co-founder of Gyoza Games in Austin, Texas. Prior to that, I was CTO and co-founder of a company called Phaser Lock, which was a company that created a launch title for the HTC Vive called Final Approach. I don't know if anybody has played that game, but so yeah, after we launched Final Approach, then I left the company, sold my shares back to my partner, and started Gyoza Games with a new business partner, John Paul Summer, and we've launched a game called Inbound, which was released on Steam in July. A little bit about my background before we get into the subject matter. I started life in the 80s professionally working in the coal industry in southern West Virginia as a mine planner and liaison to the Mine Safety and Health Administration. Basically, if there was an accident or a fatality in an underground mine, I would have to go out and make drawings and documents and so forth and present those to MSHA. Then I decided mine deaths were not something I wanted to deal with every single day of my life, and came to Austin to become a game developer for Iguana Entertainment, working on All-Star Baseball and South Park, and a few other games in the various game companies around Austin at the time. Then started a company in 2003 to do industrial machine vision systems, basically designing laser scanning systems for a variety of industries. I have 4 patents for a high-speed automated railroad track inspection system, for example. I developed some carbon fiber inspection for the Boeing 787, did nuclear waste containment inspection for Sweden, some things like that. But eventually that kind of got tiring, and so I got back into the VR after a brief stint doing mobile games and mobile projects, including some work for NASA. So yeah, I'm back in games now, basically doing VR, which is probably what I'll spend the rest of my life doing, because VR is pretty awesome. So I wanted to talk a little bit about, first of all, user experience versus user interface. And a lot of times today, people use the terms interchangeably, but that's actually a fallacy. User experience, user interface focuses on the layout of a piece of software, the aesthetics, the organization of menus, and things like that, very mechanical sort of aspects of the software that you're creating. User experience asks the question, what is the user attempting to accomplish? How can the software help the user do that in the most simple, most straightforward way possible? So, borrowing the be like meme here, programmers be like, I got this cool drill I built. It's got a 10 millimeter keyless chuck. It's got an LED light. It's got variable speed motor. It's got 2 14.4 volt batteries. All these cool features. It's very ergonomic. It's shiny. It's state of the art. Users be like, I need a hole. And I don't really want to use your drill at all. I don't care how cool it is. Unless it makes me a hole, I don't care about your drill at all. So it's very, the user's perspective on this particular problem is very, very pragmatic. And the programmer's perspective on this problem is very sort of tech and geeky and really freaking out and making it as feature-laden as possible. And sometimes in that process, the user gets forgotten about. The user really only cares about the hole. And if they had a way to make that hole without buying your drill, you would never sell a drill. Also, here's another good example. How many people can drive a stick shift? So yeah, you guys are tech people. You like the better gas mileage. You like the precise power when you need it, so you can downshift and get past the Yugo on I-10. And the best part is, if your battery dies, you can push that sucker and drop that clutch, and you will start your car. You can't do that with an automatic. All those are great features. However, as of August 2013, only 3.9% of new cars are sold with manual transmissions. Why is that? Because people don't really want to drive somewhere. People want to be somewhere. And so they don't care how cool it is to drive the car. The car is simply a means to an end. It's a way to get from point A to point B, and that's it. We don't care about. I mean, we care about it in that it improves the comfort of my transportation to point A from point A to point B. But if I could teleport and press a button, I would never drive a car again, right? So what is the best user experience? A user experience should allow the user to do exactly what they want to do in the most efficient way possible and basically get out of the way. And humans do think like humans. They don't think like programmers. Programmers are all about feature sets and buttons and all this other stuff, but really they need to take their mind and put it on the shoulders of a simulated human being and say, how is the human going to use my software? And I show this picture here because in the mid-'80s, I was working in mine engineering, as I told you, and I was doing mine planning on AutoCAD, very, very early version of AutoCAD. And AutoCAD at the time was very, very new software, and it was all running on PCXT class machines, earliest PC that you can imagine, the 8088 processor, which was super, super slow. And every time you type the regen command, R-E-G-E-N, the entire display would redraw segment by segment everything that you had modeled up in your CAD program. Well, there was cries in the audience, in the user base for this to be faster. Everybody wanted it to be faster because it took so much time. But strangely enough, the AutoCAD programmers thought just the math and the pure coolness of watching this thing be redrawn was so awesome that they didn't want to speed it up. They loved to sit and watch it was just a magical experience for them to sit and watch the drawing be regenerated so slowly. And so it actually gave birth to companies like Nth Engine at the time, which was one of the first graphics accelerators. Way, way, way before graphics accelerators for video games were around at all. So now we go from, we know what we want to do. We want to create a good user experience for the user. Now we have to go through some input mechanism. So we have to talk about interfacing. And the concept is every input device ever invented is an attempt to bridge the gap between human thought and desired action. So we started very briefly at the dawn of the personal computer, this is an Altair 8800, where the interface to the computer was a series of switches and mountains of documentation that told you which switches you needed to set before you could store a byte into memory, and then you would store all these bytes into memory, and then you'd throw another switch and it would execute the program, and hopefully if it worked, the LEDs would light up and blink in a way that made sense to you for whatever program you had written. Very, very primitive. So the real beginning was the keyboard. So that's when we really got serious about input. Anybody know what computer this is, just for trivia? TRS-80 what? I need more specific than that. Nobody knows? Okay, so I'm the oldest guy in the room. That's what we're saying. I'm the oldest guy in the room. That's a TRS-80 Model 3. That's the first computer I ever used. Which I'm not so old that I didn't use the 1 and 2. So that I'm not super old, I guess. So I didn't use 1 and 2. I used Model 3. So the keyboard, you would think that is the ultimate, for a new user, that has got to be a pretty approachable user input device, right? Because the natural inclination of a user at a keyboard is to type in English commands of what they want to do. But it didn't work that way because programmers got involved. And they came up with things like $grep file does not exist, error _log, piping symbol awk print $13, blah, blah, blah. Nobody can remember that. So what do? We have to print ridiculous amounts of documentation so that the user can have any hope whatsoever of using this computer system. But then a company called Infocom comes along and creates a game called Zork. So Zork implemented natural language processing, and it was magical. You could actually type, so I don't know, first of all, how many people here know what Zork is? And maybe even have played Zork?
I haven't seen that picture in 20, 25 years.
Yes, and even 25 years ago, it was 10 years old. So yeah, so Zork was basically, it was what we call, the genre was called interactive fiction. So instead of graphics and guns and all this stuff being rendered on screen with some sort of realistic fidelity, what we had was a paragraph of text on the screen that says, you are standing in front of a house and there's a mailbox here, and it's whatever the description of that particular scene was, and you literally typed in plain English language sentences what you wanted to do, and the system would respond. So you could say, put the lamp and the sword in the case, and it would know what to do. Sometimes it wouldn't know what to do because, let's face it, in the 80s, the parser wasn't that sophisticated, but it was actually quite sophisticated for the time, for sure, and very capable. I mean, you could put compound sentences together, and usually it would figure out what to do. And after a while, you would come to know how to interact with it and make it react properly. But the cool thing about it was, a new user could sit down. My mom could sit down and play Zork with no problem at all. My dad, anybody. My grandmother could sit down and play Zork. Also, failing was fun. So like if you type something, the programmers were clever enough not to say something like error or something like that. They said, oh, that's a really interesting request there, but I really don't know what you said. It was a very human-like response. And so those two things encourage the user to push the limits of that interface. I want to try, experiment things, and I want to fail, and it's really fun. And well, just back to this one thing. If during that time, software engineers had the inspiration to apply this technology to other apps of the day, that would have opened up computers, I think, to a lot more people a lot sooner. But instead, we still had like WordPerfect. I don't know if you guys used WordPerfect, which is a defunct company now. They had such cryptic commands to use their word processor that it was unbearable. I mean, unless you really studied the documentation, you would never know how to use their word processor. So now we got the mouse. The mouse comes into the picture. Of course, Mr. Scott here is not using it in the appropriate manner, which would make anybody know what the movie is. I'm assuming everyone knows that movie. But that is one of the funniest scenes in the Star Trek franchise there. But so now we've got a pointing device. We don't have to remember all the commands anymore. Now programmers can put buttons with English language text on the screen, and you can click them, and the software will respond in a way that's predictable. The problem with that is programmers kind of went nuts with it. They put buttons everywhere. They put buttons under cascading menus and all this stuff, and it was suddenly we've inundated the user again with way more information than they need, and we've presented it in a way that's not really efficient or responsive. So that didn't really work. So now here we are in VR. Now we've got a whole new set of input mechanisms. We've got, for the simplest VR devices like the Gear, and even the Oculus if you don't have the game controller, you've got gaze tracking. So you can look at something and that thing will react. If you stare at it long enough, it will do something. You can also use the game controller, which I think is only really something gamers will understand. Every time I hand a game controller to an adult who does not game, they don't know what to do with it. I mean, there's a lot of buttons and knobs and things, but it doesn't really, it's all very abstract and doesn't make sense to them at all. Then you have the more advanced systems like the Vive, and soon the Oculus Touch, which launches on December 6th. Now we have a way to put our hands in the space and track those hands in VR. And so that represents, I think, now we're coming back full circle, a way for a normal user who does not speak technology to have a competent and efficient way to interact with the software that you're creating. So, but now there's a new set of challenges because this is a whole new space, and we're still learning, by the way. This presentation will not be the be-all, end-all, of course, of what user experience in VR should be. It's more or less a starting point. So the first thing to remember in VR is the developer's not really in control directly of the user experience. In VR, it's sort of like you see these new VR movies that are being created, and they're beautiful and they're brilliant, but you don't have control of the camera anymore. If you're watching a movie at the theater, the producer and the director of that movie show you exactly what they want you to see, and you have no choice in the matter. But if you're showing me something in VR and the action's happening here, I might be staring over here and just having a good old time looking the wrong way. So I gotta, as a content creator, I have to direct the user's attention over here without forcing the camera to do it on its own, because that's very uncomfortable for the user. You have to rescind yourself, relieve yourself of that kind of control over the user experience. You have to suggest to the user what they need to do using cues, using audio, using visual effects, whatever. Attract their attention to where you want them to look and rely on that to get them focused where you want them. And the point of VR is to have a virtual presence. We already know how to use our eyes and our hands in the real world, so using them in VR there's really no learning curve at all to that. People get in there and they know what to do. Just a quick anecdote, my first VR game was Final Approach. And Final Approach was really, Final Approach, first of all, for those of you who don't know Final Approach is basically, you're in an environment with airplanes, and you've got a little airport down here, and you can touch with your finger, drag an airplane, and draw a path for that airplane to follow, and he will follow it down and land. That's the core concept. And this was an amazing thing, because we would bring in, at the time we were looking for investment, we would bring in people to look and play the game, and they would have no learning curve whatsoever. They could put the headset on. They knew with their hands instinctively they wanted to reach out and touch those airplanes and bring them down to land, and they had no trouble at all doing that whatsoever. So it was really one of the first times that I can remember ever creating a piece of software that required almost no learning curve whatsoever. They just intuitively knew what to do because they were using their hands, something they've been using since they were born. So, and I thought this was really funny because it really does prove that people do buy into VR wholeheartedly. This is a kid getting ready to do a face plant because he's leaning on something in VR that's not there. And this has happened, it happened certainly in our company several times, where someone, on one occasion, somebody just takes off sprinting to run at something that they see way off in the distance, and then they hit the wall. So, they really buy into that and being inside that environment. So that's another thing, as an experienced designer, you have to be mindful of, is that people sometimes forget that they're in VR, and so put in safeguards that that naturally prevent them from doing that kind of thing. So one of the design principles that I try to stick to when I'm creating a new piece of software is I want to let the user explore. And again, this is perfect. Back to the Zork parallel there. Having a VR environment is perfect for that. People like to explore in VR. It's not. It's a natural. Again, it's a natural extension of reality. And again, we want to direct the attention using other things other than physically steering the camera where we want them to look. We want to use sounds, characters, effects, whatever, to get them to look where we want them to look when we want them to look there. When they do react in a way that we want them to, we should give them some sort of feedback that says, you're doing what we want you to do. So somebody either says something in the game, or if you're not doing a game, if you're doing some sort of non-gaming application, oil and gas, whatever, then you can play a sound or show something, whatever, go to the next step in the process. Give them some positive feedback that they're doing exactly what you want them to do. And so now we're back to Zork. Zork was a very formative thing in my life, so I like to think about Zork a lot. So I played a lot of Zork, and I created a lot of Zork-type games. But we want the user to be happy exploring. We want to encourage them to play with the software and not be afraid to break the software. I've used so many industrial applications where it's like walking on eggshells. You click the wrong button, or you go the wrong way, and the system crashes, or it just gets into a state that the user can't recover from, and that makes them afraid to use your software. So we don't want that. So I'm not going to talk about this too much, because I think game controller interaction should be pretty much limited to games. I don't think game controllers really have much of a place outside of the game environment. I think for non-gaming applications, you'd want to use some other sort of input device. So gamers are the most ideal user for game controllers, so let's leave them to the game controllers. So that gets to knowing your audience. So if you're developing games, obviously gamers are your audience. If you're developing oil and gas, or if you're developing educational software, if you're developing all these other spaces, identify that customer, identify that user. What are they going to be doing with your software? What's their skill level? What's their history? What's their expectations about what the software experience is going to be like? And and make no assumptions. Ask them questions, but there's a caveat to that. If you're asking them questions, ask them not how do you think this should work, because they don't know. They're going to make wild guesses, and it's going to be wrong. They're going to ask them what they want to accomplish, and then you as a software engineer or a designer, it's up to you to create this this interface that is efficient and allows them to do that in a most efficient way. But if you ask them, they're going to say, I don't know, put a big button over here, and it's going to be wrong. It's going to be completely wrong. But so the question that is very important to ask. What are you trying to do? And then let's go from there. As the designer, that's your job, is to figure out the best way to present that in a way that's most efficient. So you're designing from the user inwards, not from the software outwards. I thought this was a really interesting case study. This is a non-interactive short film created for the Oculus Rift. It debuted at Oculus Connect last year, and it's not interactive at all, but it does a fantastic job because you're in VR and all this stuff is happening all around you. It does an excellent job of drawing your attention where it needs to be to see the things that are going on that they want to present to you. So there's behind where this camera is right now, there's like a little recessed area where his bedroom is, and there's things going on down there, but you can hear them, and so you're naturally inclined to turn around and hear what's going on down there. And then suddenly, something else happens back in the front, and you can hear that too, and you're inside the story. So I thought that was very cool. Who here knows about Job Simulator? Everybody's played Job Simulator, I'm sure. It's my friend Alex Schwartz. This is, I think, one of the most popular VR titles ever created, of course. And I think the reason is because, again, people put on the headset and they grab the controllers and they intuitively know what to do, because what do you see here? 2 hands. I know what to do with hands. I've been using hands since I was born. So they grab, what do they do? First thing they do is pick things up, throw things. They're not playing the game so much as just interactive. It's a toy. It's an interactive toy. So you can pick up things. You can experiment. The one thing about Job Simulator is it definitely encourages the user to experiment with the environment, which is a great thing. And the sales reflect that it's a great thing, because it's one of the highest grossing titles out there probably right now. So even on the new PlayStation, it's one of the most downloaded apps on there. So yeah, there's no rules. The robot gives you some vague instructions, and you go off and do your thing. Non-gamers are playing it and having no issues at all with it. Oh, tomato hands. Got to talk about this. Alex Schwartz is a genius. He's created the system where, so one of their problems was you pick up something with your hands, like a bottle of ketchup or something, and now your hands are sort of interfering with that ketchup. So your fingers are kind of sort of penetrating into the side of the bottle, and it looked very unnatural. So what he did was he hides the hands. Basically, the hands disappear when you pick something up, and the thing that you're holding now becomes your hands. That's the manifestation of your hand. And so you don't even realize it's happening. I don't know if you've noticed it in Job Simulator. When you pick something up, your hands disappear. But it's not uncomfortable at all, because now you still have something there representing your hands. And I thought that was really cool. And of course, again, skeptical. Job Simulator is selling very well. Congratulations to Alchemy. This is another really good user experience case study. This is Oculus Medium. I don't know if any of you used Oculus Medium? You have. So Oculus Medium, for those of you who don't know, is a 3D modeling program, sculpting program, frankly. that you actually use in VR. So you put on the headset, you put on the touch controllers, your hands, and you're actually sculpting in a virtual space in front of you. You can rotate things around, and you can draw, and you can push and press, paint directly on the thing. And this is my business partner, who's a world-class artist, John Paul Summer. He created these in that software, and now he is so inspired in using that software that's the only software he uses for 3D modeling. It's not the only software he uses, but he starts with that every time because it's such a liberating and inspiring piece of software. He can get in there and start playing around and sculpt out his ideas in such a free-form way that it's very free-form for him to use, and he loves it. So he created, I forget, neither of these took probably more than an hour to create. Yeah. These are using the touch controllers on the Oculus, yes. So that's what he starts every new concept, every new idea. He jumps right in. He was actually at the Oculus Connect 3 just a few weeks ago. Some of his work was 3D printed by Oculus and displayed there on the display case. So it was really, really nicely done stuff. He's a genius. He did 20 minutes in Oculus Medium. It's insane. And I mean, I'm not an artist, so this would take me like 20 years, and it would look like stick figures. So, just a few final points here. The rules and best practices that I just went over, all still being written by new developers every single day. This is all still the wild, wild west. You can do anything you can think of, you can do and try and see if it works. It's the main thing is test, test, test. Don't wait till the end to test. Bring people in to test your experience as soon as possible and very often. Bring them back and be responsive to their feedback. This was very helpful for us on Inbound when we did our most recent game. Having the user come in and try the game and see what they did like and didn't like. You as the developer are way, way, way too close to the project to have any sort of objectivity when it comes to evaluating the user experience of your own software. You have to have that objective third person come in and give you some honest feedback. And that's, last thing, if you have a chance, you can YouTube this guy, or also he's got a book called Why Software Sucks. He's an excellent speaker, and he's a Harvard professor, and I highly, highly recommend the book and if you can find his interviews and so forth. That's very, very good stuff. And I guess that's it.